Welcome to the Neural Implant Podcast, where we talk with the people behind the current events and breakthroughs in brain implants in an understandable way, helping bring together various fields involved in neuroprosthetics. Here is your host, Ladan.
Hey everyone, and welcome to the Neural Implant Podcast. Today's guest is Iain McIntyre, and he is a co-founder of Humm, or thinkhumm.com. And what this is long kind of Band-Aid looking sticker that you put on your forehead, and it improves your working memory. So basically you can focus better, you can remember more, multitask, and it's kind of a mental boost without the stimulants. Really cool stuff. Really, I'm just like, man, this is like perfect for students. But Iain was also saying it's perfect for older people who may be having senior moments, or it's perfect for executives. So really cool stuff. They're going to be launching it pretty soon. They're going to be launching it next year. They, been venture backed and everything like this. We actually met back in November at the Neurotech Leaders Forum in San Francisco, put on by Neurotech Reports. And they had, a really good presentation. And so we're recording this right now in the middle of the COVID pandemic. And they were saying, man, it's good that we raised funding before this because the funding nowadays is no bueno. But hopefully you guys enjoy this. And man, don't you want like a smart patch that'll make everything easier, learning faster? That'd be cool. So take a listen. Iain McIntyre of
Humm
is the website. Okay. And basically your device is a wearable tACS device that allows you to have more working memory. Remember, focus, multitask, mental boost. I mean, like, geez, this sounds like, the magic thing for students. First of all, thanks for coming on. Do you want to explain what you are doing with Humm?
Yeah, no, thanks for having me. So, anyone who goes to our website will see that some of the things that we're putting up as the benefits of using Humm are pretty hard to believe. And that's a pretty rational response to have when someone says that they can put a patch on your forehead and it'll make you smarter. So, it's good to explain where those things are coming from. So basically, Humm is a consumer hardware company. We've developed a much cheaper and easier way for people to access neurostimulation, taking the traditional design of a cap or a headband or a pair of headphones and bringing it into a much smaller design that's both cheap, a couple hundred times cheaper than a lot of the devices that are out there, and easy to use. It's about as easy to use as a sticker, and quick and unintimidating in that way too, that you put on your forehead. It puts a very tiny electric current in tACS, we call it. It's about 6 hertz that we're stimulating at the prefrontal cortex, the bit just under the forehead. And what that seems to do, relying on a couple of studies that came before us and some of our own studies using the patch to replicate those, is boost fundamental working memory. We've measured it most effectively on visual spatial working memory, which is basically coming across a situation that's randomized and being able to piece together how it changes. If anyone's familiar with the reverse Corsi block test, that's the test that we've published in our white paper using the Humm patch, which is a test where you see these flashing blocks and you have to remember the order randomized in reverse, and it gets harder and harder. It's a very frustrating, difficult game. But basically that is an indication that we're able to improve working memory. And then if you can improve working memory, all of the things that are incredibly dependent on working memory improve too. So your ability to acquire new skills, to adapt and multitask, to rapidly changing difficult high volume information situations, focus easier, those kinds of things. So that's what Humm does.
What kind of working memory improvement is there? Is this something like that a statistician has to go in and be like, oh, there's like a 0.3% increase or whatever we can call it, statistically significant, or is it just like 100 times better?
Yeah, so in our placebo-controlled study that we did here in Berkeley, we saw a 20% improvement on the reverse Corsi block test against the placebo, and that was measured over a couple of weeks, controlling for expectations of the people that were involved in the study, age groups, genders. All the details are in the white paper. It was double-blinded as well, which is really important. And what we found was that on the reverse Corsi block test, on average, people went up by 20%. We found a 95% response rate too. So 95% of the people who got the real stimulation versus the fake placebo version, which still involved putting a patch on, found that they actually did improve. 20% improvement may not sound like a lot. These days you think about percentages for a lot of things, like what would it be like to use 20% less time, etc. But when you're talking about what you can do with your brain and your ability to learn skills faster, focus easier, 20% is pretty incredible. There's no technology out there that does that doesn't require brain surgery at the moment. There's nothing out there that will do it that quickly, that dependably, and without side effects as well. So it's pretty awesome. That's a scientific study. When you actually look at real world results, there's a lot of other variables, physiological inputs into how someone's working memory is operating, stress, alertness, and just the quantity of sleep, the quality of someone's diet and exercise. Those kinds of things are really important too. But what I'm saying is that it's not necessarily a 20% improvement you can rely on in every activity you do. You also need to be doing difficult working memory dependent tasks to really notice the effects of Humm. But it's pretty transformational from what we've seen with our testing with people in the real world for things like doing really difficult mathematical problems, coding, learning new skills like instruments and languages. So pretty cool.
That is interesting. That is pretty cool. And again, this sounds like the perfect kind of thing for students. So what does that mean? I mean, 20%, what would that translate into in like a real world thing? So like you're learning the instrument 20% faster, or you are able to do it 20% better? I mean, in something like that, what would that 20% translate to?
Yeah, so that 20%, you shouldn't try and directly translate that into a measurement of a real world activity. I think that, first of all, there's a lot more data to collect here. One of the things that we're taking our time to do is to collect a lot of data on real world activities with various levels of control on other factors. So you get different results when you test someone in a lab with all of the factors controlled than you do in the real world, where fundamentally a product needs to work for people to use it. We are taking our time to do a combination of lab testing and real world testing, giving people the product to take home. And I can tell you that 20% doesn't necessarily translate into you get 20% faster at studying. What you find is it's a bit like compound interest. You sit down and you study. If you study several times with a patch, you'll start to notice that you're learning the material much faster. People have quantified it anecdotally, and remembering that placebo is important when you're talking about real-world testing. People's experience can be really different depending on what circumstances they're in, etc. But we've seen everything up to 200% improvement in speed. People talking about how they could get through more flashcards came back to us that they were able to memorize a body of material 200% faster. Incredible. But I wouldn't say that that's a reliable thing that everyone could expect. I think that was a reasonably controlled circumstance. People were doing quite a difficult problem that they hadn't encountered before. It was reasonably controlled circumstances. We prescribed to them how to balance their coffee intake and make sure they were measuring their sleep and things like that. That being said, when we've given people the opportunity to try it on their own terms without any of those kinds of controls, we still see pretty significant improvements. And the compound interest thing that I mentioned is to say that you're getting this incremental benefit every time you wear the patch. You're not becoming superhuman. It doesn't replace sleep, exercise, diet. It doesn't necessarily replace caffeine either. But when you use the product, when you use this technology to improve the way that you're practicing, improve the way that you're studying, over time, just like compound interest in a bank, you learn things much faster. So the longer someone uses it, the better it is. And you do notice every time you use it when you're doing difficult things that you get an incremental benefit too.
Okay. And so what does it feel like? Do you feel like an electrical current going? Is it kind of like putting your tongue on a 9-volt battery?
Yeah, it's really, really light. A lot of people have had that experience of that 9-volt battery on the tongue, right? And even trying some of the other tACS devices that have been out there before, people's expectations that it's going to sting or that it's going to burn a little bit or anything. Actually, one of the cool things about tACS, one of the cool things about the placement that we've got, the types of electrodes that we're using, is that when you put this little patch on your forehead, we've got quite a large area of connection so that the feeling isn't really like having an electrical arc of any kind. It's pretty spread out over the skin. You're getting good adherence. We're not having to go through hair or anything like that. So it's a very even adherence of the electrode. And the type of electricity, the tACS, it feels milder. It doesn't feel as intense as a DC feeling. Like if you've done the 9-volt battery thing, that burning kind of zappy feeling, the metallic taste, we don't typically get that. So what people usually feel the first time is they feel a bit of tingling. Some people describe it as a warm feeling, some people as a cold feeling, some people as a tapping. It's definitely noticeable. Everyone who wears it notices it. I've only ever seen a couple of people not be able to notice it, but it's pretty mild. There's no kind of burning feeling. One thing that pretty consistently everyone notices that's different to any of the other types of this, the TMS and the magnetic stuff and the tACS. tACS actually, when you're inverting the electric current at a particular frequency, in our case 6 hertz for this first product, you'll see flashing in your eyes, something called phosphenes, just little tiny bits of electricity passing the retina. And the retina is super, super sensitive. So you'll see when you wear the patch a bit of a strobe effect in your peripheral vision. It's kind of something you don't really notice after the first time you use it. But if you're in a dark room or you close your eyes and push your hands up against your eyes, it's an interesting effect. It's pretty novel to people, and people are often surprised by it. But when you tell them that it's coming beforehand, it's not very concerning. So, yeah, I mean, overall, the patch is a pretty chilled out thing to use, which is what we're going for.
Wow, that's pretty incredible. I didn't know that there were actually these kinds of physical manifestations of everything. And, that being said, is it safe? I mean, if you're using this a lot, are you going to get like forehead cancer or something like this?
Yeah, it's a good question. I think it's an important question for people to ask of these kinds of things. And we're building a body of evidence to show beyond what's in our white paper already that using Humm in particular is safe. But the area of tACS has had many tens of thousands now of study participants. The amounts of electricity that we're talking about, really the worst possible thing that can happen is skin irritation or a headache. And typically that's in a very small number of people, pretty similar to the number of people that would just develop a headache in a weird situation like having an electric device strapped to your head anyway. So we haven't seen any serious side effects from anyone using this stuff in the labs, nor in the products that have been rolled out into the real world, devices like Fisher-Wallace, Halo Neuroscience, Think. None of them had any kind of serious side effects. The amount of electricity that we measure is actually getting into the brain when we do lab tests with this technology is really small. We're using something like 2 milliamps just on the skin. Obviously, some of that gets blocked in the skin, dissipated by the skull, dissipated in the cerebrospinal fluid that's on top of the brain. So you really are getting a very small amount of electricity actually into the brain too. So it's not really able to cause any fundamental, long-lasting chemical or physiological changes. It's causing kind of an emergent change in the brain waves. And so no, you don't get any kind of cancer. You're not really causing any kind of long-term changes whatsoever. And the worst thing that anyone could ever experience, but they don't seem to with Humm, is a little bit of skin irritation and maybe a headache.
Okay. And then your guys' devices, they're disposable. It seems like you are supposed to use them for maybe 3 days and then you throw it away. And it has like batteries inside and everything like this. Why did you choose to do it disposable instead of like, rigid device or something like that?
Yeah, so this technology isn't new, is it? I mean, the science is young. We're on the bleeding edge of this technology in terms of commercializing it for sure. But transcranial stimulation has been around for something like 40 years now. The first FDA-approved device in the space was in the 1990s. That was the Fisher-Wallace, which is now prescribed by like more than 12,000 medical doctors in the United States as a treatment for depression and anxiety. So it's not new, but we haven't seen kind of any large uptake of this technology. There have been more and more exciting results in labs, like at the Neuroscape lab at UCSF, where we worked at New York as well, New York University's neuromodulation lab. But the devices that are used in the labs are very difficult to take out of the lab. So what really inspired our company in general was to be able to translate that new neuroscience into benefits for people, starting with healthy people, consumers, where we're not a medical device, starting with healthy people who in labs had been observed to be able to learn things faster, acquire skills faster using this method of neurostimulation we use. And then in the longer term, to be able to treat all kinds of things, conditions like mild cognitive impairment. Even further down the track, would love to do something for Alzheimer's. But the thing that's really standing in front of anyone making a device that people will get those benefits out of is not that the science isn't working. It's that the devices are not like adoptable. They're not approachable. They're expensive. They're difficult to use. They're intimidating. They're kind of embarrassing to use in front of people. And so for that reason, everything that anyone's ever tried to commercialize has got a bit stuck in a niche use case or a medical use case. And we spent 3 years working on this in Australia before we moved over here, and then over here at Berkeley as well. How do we actually address that problem? And we did a lot of testing with headband versions of the patch that came before what we're working with now, and found that people were actually reliably able to perceive benefits for several months using the headbands. But the difficulty of wetting sponges, adapting it to different head shapes, carrying around a headphone case, and the thought of having to pay upfront $500, $600 was just going to fundamentally limit how much data we could collect testing with people was one thing, but then also how adoptable it could be at a broader scale over time. And so we decided that our first product, not our only product by any stretch, would be this disposable patch, which is basically as easy as a Band-Aid, as cheap as a cup of coffee, and about as scary as a face mask, so that people could get the experience of using neurostimulation, see the effects for themselves, test it themselves. We could give them to scientists and they could use them quite easily. And then we can spring launch from there into the more reusable stuff to start off with, and then the more complicated stuff as well, where we're doing different types of neurostimulation and different novel formulas of combination of neurostimulation and neurosensing to improve it overall too. So that's what we're going for.
Yeah, that's pretty interesting. I mean, you said that the standalone devices were 500, and I repeatedly said I think this is really good for students. Is this something that you guys are aiming to be in the students' price range, students' budget?
You know what? We have some pretty interesting thoughts on this that I think maybe a lot of people haven't. So when we started the company, myself and Tim and Ahmed and Chris, my co-founders, we're all pretty fresh out of college, and just naturally assumed that the people that we were most excited or recognized the technology would be immediately applicable to would be college students. First of all, when you're at college, you're constantly cramming, you're constantly pushing yourself. It's pretty difficult and counting a lot of information really quickly. But then also when you get out of college, you realize that everything you've learnt, first of all, is going to be obsolete within a couple of years. And then second of all, it didn't prepare you for your job. I was going into law, Tim was going in medicine, Ahmed in engineering, and all of us were going to have to learn everything we had, more than what we had learnt in college, in an even shorter time to learn how to do our jobs and progress. So yeah, there's a good application in helping people learn faster, absolutely. But interestingly, testing with different groups of people, we found that college students were one good group of people, but there were lots of other people that really demanded the ability to learn things faster. A really interesting place that we found was even better than college students was actually older people. People are starting to notice that natural deterioration in working memory, which is not any kind of medical condition, it's just natural aging. Everyone who gets past the age of, say, 25 starts to notice that it's a little bit harder to learn a new language than it was when they were 12. And that's just a natural process that we've all accepted. It doesn't mean that our patch, nor this technology in general, causes any greater effect for someone who's, say, 25 plus, but a lot of things stack up that make someone above the age of 25 appreciate it more. First of all, younger people, students, are typically less developed in their understanding of how their sleep patterns need to work, their diet, their exercise, use of caffeine, these kinds of things. The older you get, the more you kind of come to know your ability and your baseline and be able to better manage it and be more used to managing it. But then also, the older you get, the more you're appreciating the boost that you get in working memory. And in our study and the studies that we're linking the patch is based on, it doesn't seem like the patch actually causes any greater improvement in working memory for an older person. In fact, it's pretty consistent across age groups and between people. But people over the age of 25 who are really looking for an evidence-based, reliable tool that can give them a mental boost really appreciate it. And particularly the groups of people that we've had the best adoption in the proof of concept and then the alpha stage have been people like executives, scientists, medical doctors, data scientists, all kinds of white-collar jobs and high-performing people who are looking to continue to learn things or are looking to build towards like a professional examination, looking to do personal development, or even just looking to make something like their nonfiction reading more valuable for themselves. So we are interested in students and we have done quite a lot of testing with them, and it does seem to be a really good target use case. But we're actually really interested in this older group of people as well.
Yeah, that is actually really interesting. Yeah, I think, like you said, students may be overcaffeinated, underslept, or something like this, and they might not realize all the benefits of it.
There's going to be coaching and other things that we're building into the case, and we've actually we raised money late last year and decided to extend our launch date so that we could work on some of those tools. Basically, it's just different for different people. The use cases for an older person are slightly different to those of a younger person. Typically, a younger person's looking to use it more often in a day and cramming in big blocks, whereas the older people that we've been working with are more interested in doing staggered learning over the course of a week. Both are interesting use cases, and it's exciting to be able to help both of those people too, even just with this first product. But yeah, I don't think a lot of people realize that this technology is actually really helpful and really demanded by people who are out of college as well, which is cool.
Yeah, it is. Maybe we'll see a bunch of professionals walking around with this patch on their forehead in a few years. So
I think it's going to be a bit like the AirPods. Of course, I'm biased. And I remember a time when I thought that people wearing AirPods looked a bit strange. I'm sure we all do. But at the moment, really people are most comfortable using it at home. Makes sense. It's a weird patch thing that you put on your forehead. It's a very new technology. Not many people have heard of it. The common reaction the first time you hear of it is to associate it with the things that you're familiar with that talk about brain and electricity, like Total Recall or like the electric chair. This is all pretty rational reaction because it's just so new. And for that reason, I think most people want to start using it at home. But once people get a bit of confidence in understanding the science, understanding how they feel when they use it, getting used to wearing it on their head, people actually do start using it outside of home. And I've had a lot of people use it in cafes or at their workplace. And it starts conversations for them, which can be distracting in and of itself and kind of defeat the purpose sometimes. And that's maybe a good reason to use it at home or when you're like by yourself learning. But it's cool that we're starting those kinds of conversations for sure.
Yeah, that is really cool. I mean, it's a 15-minute session that you have it on, and then it provides 2 hours of improved mental performance. So is there any other benefits afterwards, or is it really just during that short window?
Yeah, great question. So with a 15-minute session, you're actually able to perceive the electrical differences in the brain in sometimes up to 24 hours afterwards. So there are and behavioral effects. Of course, it gets milder and milder the longer it's been off, but you are able to perceive an effect. Though in the real world, we're pretty positive that the noticeable effect against a placebo is much shorter than that. There is some variability between people and between days that you use it. So it's important to kind of, from our perspective, to give people an amount of time, a duration that they could rely on it being useful that's pretty short from that perspective, so that you're not using it and being disappointed if it's not working 3 hours later. Reliably, we've seen about an hour and a half of noticeable behavioral improvement. So you'll be able to notice the effects for about an hour and a half afterwards pretty reliably. That doesn't mean that those effects don't sustain, but we're not causing any underlying changes in the brain. We're not boosting memory overall in any way. It's not kind of changing the brain to make it work better in the long term. But when you learn something faster with the help of the patch, when you acquire a new skill or acquire more information or just improve your retention by storing things a bit better, that sticks around. And that improvement is kind of like compound interest. That's what I was alluding to before. If you use a patch 3 times in a week, you'll find that the next week you can learn faster. It's like going to school and learning how to learn, except you're not having to put that extra effort in, having to spend time learning how to learn. You just put this patch on and it gives you that baseline boost.
That's the dream, man. You got to send me some samples when this is ready to go. I would love to use this for my personal use. I won't tell you exactly what. Yeah, Iain, this has been great. Is there anything else that we didn't talk about that you wanted to mention?
I know that a lot of scientists and academics listen to this podcast. I think a lot of people would be really interested to read our white paper and find out the longer term vision behind what we're doing here. Our website is www.thinkhum.com. On the science page, there's a link to download that white paper. You can read about our trial. You can read about some of the studies that inspired what we're doing, the people that we're collaborating with. And I'd be really excited to talk to anyone who's interested in collaborating or finding out more.
Yeah, I hope that happens. I hope this podcast opens that up for you. So Iain, thank you so much. This has been excellent. This has been very good.
Awesome. Thanks for chatting.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.